So far, we know that wherever the function of a graph cuts the x-axis, it is at that very point we get a root. Okay, but what about equal roots? How can you define them? How can you observe them graphically? This is something that will be the agenda of today's session. We are not going to just solve or provide the solution to this very problem. Rather, we are going to do a complete post-mortem of it. Okay, so you have to wait right till the end. बिल्कुल बने रहना है आखिरी तक. So let's begin. In front of us, we've got a cubic equation. So let me write this again. And we've been given a condition. And that is that two of its roots are equal. What equation? Cubic. How many roots? 3 roots. Let's say alpha, beta, gamma. Out of which 2 roots are equal. Let me assume beta and gamma as equal. Instead of gamma, let me write beta. Done, sir. Let's apply the funda. And before applying the funda, whenever I say funda, remember sum of the roots, product of the roots. Okay. We are going to start from here. Negative, positive, negative. And by the way, all of these formulations have already been done. Let me show that to you once again. This is for a quadratic. How many roots? 2 roots. Therefore, 2 relations between alpha and beta. 3 roots, 3 relations. 4 roots, 4 relations. Right? Do refer to these. Better to take a photo. Screenshot. Here we go. Sum of the roots. When you apply sum of the roots, it is going to be minus of minus 11 over 3. That means alpha plus beta is equal to minus of minus 11 over 3. Simplify this. That's your equation number 1. Done. When you take product of the roots, by the way, this is sum of roots. Now you have to take sum of the product of roots. Okay. Combo of alpha, beta, and then beta alpha again. There it is going to be plus of plus 8 divided by 3. Let me do this. 2 at a time. Alpha, beta, then beta, then beta alpha. This is how you need to make the combination. Simplify. That's your equation number 2. By the way, these 2 equations are sufficient to help us get to the values of alpha and beta. But I'll also go ahead and get you the equation number 3. Simply product of the roots alpha, beta, gamma is equal to negative of positive 4 divided by 3. Okay. Alpha, beta. And that's our equation. Equation number 3. Now how to approach from here on? Draw a line. Make some space. So let's start with this equation number 2. What we can also do is we can start with equation number 1. Okay, let me write this equation number 1. From here you can work out the value of alpha. Alpha is going to be equal to 11 by 3 minus of 2 beta. And that is what I have written. And I'm going to plug in this value of alpha into this equation here. Okay, let me do that very quickly. And here it is 2 alpha beta. Let me make some space for alpha. Plus beta square is equal to 8 over 3. And that's alpha for you. Take the LCM. Just try to solve this bracket first of all. Take the LCM. 3, 11 minus 6 beta. Done, sir. Now I'll multiply 3 by both sides. What will happen in such a case is 3 from the denominator will go away. 3 from the denominator will go away. And here you will have 3 as the coefficient. Once you do the multiplication. Multiplying by 3 both the sides. And then 2 into 11 into beta will give you 22 beta. Then 2 into 6 into beta. Beta is beta square. 6 2 is 12. 12 beta square. So let me simplify this. 22 beta minus 12 beta square plus 3 beta square is equal to 8. Done. Minus 12 beta square plus 3 beta square reduces to minus 9 beta square. So this is how you need to do. That's 9 beta square with a negative sign. So you need to take it to the other side in order to make it positive. This 22 beta will also become negative. Very simple stuff, very basic stuff. I hope you can understand this very easily. Now 9 into 8 is 72. You need to think of 2 numbers whose product is 72. Okay, and whose sum is 22. Think of 2 numbers. The 2 numbers, by the way, are 18 and 4. The sum is 22 and 18 into 4 is 72. Right? So this is what we need to apply. 9 beta square minus 18 beta minus 4 beta plus 8 equals to 0. Take 9 beta as common. And here take minus 4 as common. Okay. Let me go back. Let me write this again. Here we go. Beta minus 2 is common. 9 beta minus 4 will remain. And this is how we can get to the roots of beta. So beta has 2 values now, 4 by 9 and 2. which value is correct and which one is wrong. Again, you need to do an investigation. Try to plug in this value 4 by 9 into this equation. If beta is the root, look, if beta is the root of the equation, then 4 by 9 must satisfy this equation. F of x should be equal to 0. If it is not equal to 0, then this 4 by 9 is not a root. Let's try to do this. When we do that, we realize that f of x is not equal to 0. Therefore, I have crossed it. The moment I put the value of beta as 2 into this equation, I get f of x is equal to 0. It perfectly satisfies. Therefore, beta is equal to 2 is a root. And based on this beta, I'm going to put this value of beta into this equation. Alpha is equal to 11 by 3 minus 2 beta. The moment I do that, I get the corresponding value of alpha. Okay, which happens to be minus 1 by 3. So the roots are alpha minus 1 by 3, beta is 2, beta is 2. These are the roots. But sir, how could two roots be equal? Can you observe them graphically? You surely can. Let me show that to you. And let me get the calculator out. Here it is. Okay, that's the equation. 3x cube minus 11x square plus 8x plus d. Why have I placed a d? So that I can vary its value. And this basically allows us to see how these changes are taking into effect into the graph paper. When d is equal to 0, you can clearly see there are as many as 1, 2 and 3 roots. One root is 0, second root is 1, the third root happens to be 2.667. Very well, sir, no problem, as long as the value of d is 0. But sir, in the problem it has been given d is equal to 4. Just watch what will happen if I keep on increasing the value of d from 0 to 4. Observe. Sir, the profile of the graph remains unchanged, rather it is shifting in the upward direction. Okay, we've moved from 0 to 2. Still, sir, we can see we have as many as 3 roots. Minus 0.195, 1.375 and 2.486. Right? Okay. If you go ahead, watch this curve over here. This curve over here, something beautiful is going to happen. Now, still we can see that function is cutting the x-axis at 3 different distinct locations. That means there are as many as 3 roots. What about the equal roots, sir? Keep on increasing now. 3.7, 3.8, 3.9 and 3.46, 0.7, 0.9 and done. Now you see, this is the funda of equal roots. The function will not change its sign, rather it will stay positive. Okay, the curvature is going to change. Right here, the curvature is going to change. Rather, we can say just before, you can clearly see that it was cutting at 2 distinct locations, and now this has become absolutely tangent. From here we go. This has become absolutely tangent. Whenever the axis, x-axis becomes a tangent, listen to this carefully. Whenever the x-axis become a tangent to the curve, remember there are going to be 2 equal roots at this very location. Now you can verify this. 2 equal roots, 2, 2, and here obviously the answer is minus 0.333. Minus 1 by 3 is equal to minus 0.333. Okay, so this was the entire postmortem that I wanted to conduct, so that now you guys have a clear picture about equal roots. What is the condition? The x-axis would behave as a tangent to the graph. And you can also see that here, although we have said that for a root it should cut the x-axis, here it is just touching the x-axis, and first of all it was on its way downward, then it has on its way upwards. These are the conditions. Thank you very much. If you found this video helpful, do share it with your friends and classmates. Do subscribe to the channel and press the bell icon so that you stay updated with all my latest content. This is Manas Patnaik signing off. Take care.